Hello everyone, welcome to the equation lab. Today we will be doing another arithmetic problem, so let's start with our question. So today's question comes from the AIME, which is an American math competition, and it focuses on Diophantine equations. Diophantine equations are equations where integer solutions are much preferred, so not 1/2 or a decimal, only like 2 or 3. So the question is, when the positive integer n is divided by 101, the remainder is 7. When n is divided by 103, the remainder is 9. Find the smallest possible value for n. I'll give you guys some time to do this question by yourself. So first thing is that we can write n as a multiple of 101 plus 7 and a multiple of 103 plus 9. So n equals 101k plus 7 and n equals 103p plus 9. We can then set these equations equal to each other, and we can get all the variables on one side and all the numbers on one side. So we get that 101k minus 103p is only equal to 2. Then, to make it easy to factor, we can write 103 as 101 plus 2 and then distribute it. So we get 101k minus 101 plus 2p is equal to 2. And then we get 101k minus 101p minus 2p is equal to 2. Then we put all the 101s on one side and all the other factorable things on the other side. So then we can factor and we get 101 times k minus p is equal to 2 times p plus 1. Now, we know that 101 is a prime number, so it must divide 2 times p plus 1. But it cannot divide 2, so it must divide p plus 1. So we can set p plus 1 equal to 101, and we get our p-value as 100. Then we plug it back into our original equation, and we get that the smallest possible value for n in this scenario is 10,309. Now let's try a very similar problem that will use the exact same method. So when the positive integer n is divided by 11, the remainder is 3. When n is divided by 17, the remainder is 9. Find the smallest possible value for n. I'll give you guys some time to do this question by yourself. So then we can write n as 11k plus 3, and we can also write it as 17p plus 9. Then let's set them equal to each other, bring all the variables to one side, all the numbers to the other side, and we get 11k minus 17p is equal to 6. Now, since we just need to get the same number for the variables, in this case we need 11, we can set 17 equal to 11 plus 6. So we get 11k minus 11p minus 6p is equal to 6. So then we move all the 6 numbers to one side and all the 11 numbers to another side to factor. So we get 11 times k minus p is equal to 6 times p plus 1. Now, once again, we know that 11 is a prime number, and it must divide 6 times p plus 1. So we know that it does not divide 6, so it must divide p plus 1. So we can set p plus 1 equal to 11, and we get that 10 is our p-value. So now we can plug in 10 back into our original equation, and we get that for this question, 179 is the minimum possible value for n. So our question was, when the positive integer n is divided by 11, the remainder is 3. When n is divided by 17, the remainder is 9. Find the smallest possible value for n. The smallest possible value is 179. Thank you for watching, and make sure to like and subscribe.